Welcome to chapter 20.1 to 20.2, where we're going to talk about calculating oxidation numbers, redox reactions, and how to balance them. So what is a oxidation reduction reaction, or as we call it, redox reaction? This involves a transfer of electrons. So one element will oxidize and the other one will reduce. In a redox reaction, they both happen at the same time. So both of these are happening. It's not that one happens and not the other. They both happen. When the element that is oxidized will lose electrons, okay? When it loses an electron, the charge increases. On that element. And the element that gains an electron, the charge reduces or decreases. I like to use the word reduce because reduction, reduce, so it helps you remember it. Just like the law of conservation of mass, we have the law of conservation of charge. Electrons cannot be created nor destroyed. So if one substance is losing an electron, something else has to gain it. That's why they have to both happen at the same time. Okay, so as it says here, oxidation reactions are always accompanied by reductions and vice versa. A good rule of thumb is synthesis, decomposition, signal replacement reactions are redox reactions. And then there's this little acronym oil rig where oxidation is losing electrons and reduction is gaining electrons. So that'll help you remember what is going on. I actually still use this. So before you could figure out what was oxidized and what was reduced, you have to calculate the oxidation numbers. And they help you keep track of what the electrons are doing, if the electrons were gained or lost. So if the oxidation number increases, that means the element was oxidized. So an increase in oxidation number means it was oxidized. And if the number decreases, it means it was reduced. Okay? So let's talk about oxidation first. In the oxidation process, you have an atom or ions that experience an increase in the oxidation state. They lose electrons, so that their charge increases. So the first thing you need to do is assign charges to all your elements. An element in its standard state, all by itself, has a charge of 0. So elements by themselves have a charge equal to 0. Diatomics have a charge equal to 0. When they are in the compound, though, they take on their oxidation numbers. So in this case, sodium becomes +1 and chlorine becomes -1. So if you look at sodium, it went from 0 to +1. The charge is increasing. It was oxidized. So sodium was oxidized. If sodium was oxidized, that means chlorine was reduced, because it went from 0 to -1. The charge decreased. So reduction. I kind of talked about this on the last slide too, but let's write our charges again here. 0, 0, +1, -1. You see chlorine's charge is reducing. So it was reduced because it gained electrons. So in reduction, you're gaining electrons, which reduces the charge because it makes it more negative. So again, in a reaction, you have both of them going on. If something's getting oxidized, the other item must be getting reduced. So if you look here in this diagram here, these are the charges. Sometimes it's easy to know the charges because they're written right there for you. So that's a nice, easy state. But here's zinc all by itself, so it's 0. Here's my diatomic, so it's 0. This says +1 and that says +2. So zinc went from 0 to +2. So it went from 0 +2. its charge increased, so it oxidized. Hydrogen went from +1 to 0, so it reduced. Then there's something called oxidizing agents and reducing agents. So notice, in this case, hydrogen is your oxidizing agent. And what did hydrogen do? It reduced. So your oxidizing agent is the element that reduced. So right here, what is reduced is the oxidizing agent. And then your reducing agent is the substance that oxidized. I like to think when I hear the word agent, I think of double agent. So it's doing the opposite of what you think. Or you could say what causes, so think of agent as meaning causes. What causes oxidizing? Well, what causes something to oxidize is the item that was reduced. So how do we balance these reactions? So first we have to write our half reactions. So in this example, everything has charges on it already. So let's figure out what is oxidizing and what is reducing. So remember, oil rig. So oxidizing is losing electrons, so its charge increases. So here tin went from 2 to 4, so it was getting oxidized. So what you do is you pull out the substance that's getting oxidized, and this is called a half reaction. So you write it down, and then you need to balance the charge. The charge has to be the same on both sides of the equation. So here it's +2, and here it is +4. You balance charge by adding electrons. We never subtract electrons, you just add them. So how do I get it to both be the same charge? So by adding 2 electrons, this is effectively -2. So 4 minus 2 equals 2, and that's how the charge is balanced here. Next, I'm going to look for the substance that was reduced. Here, iron went from 3 to 2. So I pull down my example here, and let's just write it the way it is in the reaction. And I need to balance my charge. So here I have a +2 and a +3, so I can only add electrons. So I need to add 1 electron to the left, okay? Now, when you're done balancing your 2 half reactions, you have to add them back together. When you add them back together, your electrons have to cancel out, which means you need to have the same number of electrons on both sides of the reaction. So this only has 1 electron, and this has 2. So what you have to do is multiply this whole reaction by 2, and that's what they did here. And once you multiply the whole reaction by 2, now your electrons will cancel each other out when you add them back together. See, they go away, and then you bring everything down, so you get SN2 plus aqueous plus 2 Fe 3 plus aqueous yields SN4 plus aqueous plus 2 Fe 2 plus aqueous. And the states are important. You should always write them. So how do we go about balancing half reactions? Well, the first thing you need to do is assign charges to all of your elements. Once you assign your charges, then you need to figure out which element was oxidized and which was reduced. Remember, the oxidizing one, the charge increases, and the reducing one, the charge decreases. So that's why you need to have the charges first. Once you do that, you could separate it into your oxidation and reduction half reactions. Then you need to balance the actual elements. So you balance all the elements that are not oxygen and hydrogen first. After you do that, you'll balance your oxygens by adding water. And we're going to go over an example of this. But by adding water, you're also adding hydrogen. So then you have to balance the hydrogens by adding H+. And the last thing you do is balance the charge by adding electrons. Then you need your electrons to cancel out on both sides, so you might have to multiply. Then you add your two half reactions back together, and if you can, simplify stuff. So let's go over this in an example. So here's our reaction. Mn4 minus C2O4 2 minus yields Mn2 plus CO2. Okay, so the first thing is to assign your oxidation numbers to everything. So I'm going to write it here, and then I'm going to erase it because I'm going to need this later. So I have Mn4 minus. Okay. Oxygen is always -2 unless it's a peroxide. So if oxygen is -2 and there are 4 of them, that means the total charge from my O4 is -8. Mn I don't know. So let's think about it as algebra. X plus 4 oxygens that are all -2 must equal whatever charge is on your substance. Let me say that again. X is the charge of Mn, which I don't know. I have 4 oxygens that are always -2, and all of that has to equal a -1. So Mn's charge is +7. Now, you might get good at this and be able to do it in your head. You don't have to write all this out if you could do it in your head. But if you can't do it in your head, write it out on a piece of scrap paper, because if you get your charges wrong, then you will never balance it correctly. Okay, let's look at the next one. C2O4, the whole thing has a -2 charge on it. So I don't know carbon, but there are 2 of them, so I'm going to call that 2x. Plus I have 4 oxygens again that are always -2. And all that has to equal a -2 because that's my charge. So I have 2x minus 8 equals a -2. So my chromium is +3. Over here, I'm going to put a -2 over the oxygen and a -2 over the oxygen. Okay, so far so good. So now this Mn has a charge on it already. So woohoo, that's easy. We don't have to do anything. It's +2. Carbon dioxide. So I don't know my carbon. +2 oxygens, which are -2. Is there a charge on here? No, so that has to equal 0. So my charge, I like red better, you can see it easier, on the carbon is +4. And my oxygen's -2. So now everything has charges written on it. That was step 1. Write the charges. Do you remember what step 2 was? If not, let's go back. Assign charges. We did that. Now it says figure out what was oxidized. So whose charge increased? So Mn went from +7 to +2. That did not increase, that decreased. But carbon went from +3 to +4. So that oxidized. So now you're going to write the compounds that have carbon in it down here. So I did it already. Okay, now we need to balance this, okay? So now that we wrote down what's being oxidized, and then we need to figure out what's being reduced. So you see Mn has a +7 and it's going to a +2. So I wrote all the reducing stuff down here. So the first step when you're balancing is to balance the elements. So I see here I have 2 carbon. I only have 1 carbon on the right, so I put a 2 there. Now that we balance the elements, now we can balance oxygens. So I have 4 oxygens on this side and 4 on this side, so it is balanced. Now I need to balance my charge. The charge over here is -2. My charge over here is 0. So I add 2 electrons, so now I have a -2 on both sides. Okay, let's look at my reduction one now. Balance my Mn. I have 1 Mn here and 1 here, so it's balanced already. But I have 4 oxygens. Do you remember how we said we balance for oxygens? Well, let's go back and look. Balance oxygens by using water. So I need to add 4 waters here so I can have 4 oxygens. But by adding water, I also added hydrogens. How many total hydrogens do I have here now? I have 8. So I have to add 8 H pluses to the left side. So now let's just double check. 1 Mn, 1 Mn. 4 oxygens, 4 oxygens. 8 hydrogens, 8 hydrogens. The last thing I need to do is balance my charge. So here I have a -1 and a +8, which gives me a +7. So +7 on this side. Here I have a +2. So I can only add electrons. So I have to add 5 electrons to this. And now my charges is +2 on both sides. A little hint for you is, think about oil rig. Oil rig says oxidation is losing electrons. If you are losing electrons, what side of the reaction is it going to be on? The products. So oxidizing will always have the electrons as a product, and reducing will always have the electrons as a reactant. Now I need to add these two together, bring my half reactions together. But in order to do that, I need my electrons to cancel. So I have 5 electrons here and 2 here. So I need to multiply both of these equations so I can have the same number. So I'm going to multiply the top by 5 and the bottom by 2. And that'll give me 10 electrons on both sides. So now I could start writing this down. So 5 C2O4, 2 minus. And now is when you could write the states again. Plus, I'm not going to write my 10 electrons because they're going to go away. 2 MnO4 minus AQ plus 2 times 8 is 16 H plus AQ. 5 times 2 is 10 CO2 plus 2 times 1 is 2 Mn2 plus 2 times 4 is 8 waters. And I have the answer written down here, so let's check if we got it right. 2 Mn, 5, 6. Yep, so we did it right. This is how you balance a redox reaction. And this is called acidic. If you end up having an H plus here, H plus, it means it's acidic. You can also balance these with something called a basic, and that's on the next slide. So balancing in basic solution. You balance it just the same way as you did in an acidic. So I copied the answer from the previous slide right here. But there's one more step. Now you look and see how many H pluses you have. And you're going to add that number of OH minus, because that's for bases, to each side. So I have 16 H pluses, so I'm going to add 16 OH minuses to both sides. These two are going to combine and make water. So now I have 16 waters But notice I have water on both sides of my equation. I have water here and here. So what you want to do is bring the waters all to one side. So I'm going to subtract 8 waters from here and then subtract them from here. So I end up with 8 16 minus 8 is 8. 8 waters, and that's a liquid. Now I'm going to add my states. Notice water is not aqueous, it's a liquid. Water dissolved in itself is a pure substance. And that would be your answer in a basic solution. So you do the same thing for acidic, except at the end you add that many OHs, which then makes this water. Then you need to look. And I had 16 on the left and 8 on the right, so I subtracted 8 from both sides. So I got rid of this, and I ended up with 8 waters. So here is your answer. At first, this seems overwhelming because it's a lot of steps, but once you get it, it's actually very satisfying to balance redox reactions. All right, well, that's the end. Talk to you soon.